So in 3.1, we learned chain rule with the derivatives. When we do antiderivatives or integrals, this is kind of like the backwards chain rule. We call this U-substitution. You can use any letter you want technically. However, it's just common practice that everyone uses U-substitution. So we're going to do some examples. It's best I just do this by through example problems. So if you have the integral of 3x minus 4 to the fifth power, watch how they do this. You can set u equal to 3x minus 4, the inside piece, right? Because this isn't an x to the fifth, it's 3x minus 4. If you take the derivative, du, so du dx differentiate with respect to x, that's equal to, well, the derivative of 3x is just 3. If you bring the dx over, now it's du equals 3 dx. So the reason why this is cool now, one sec. Before that, we have to have the dx by itself. So du over 3 is equal to dx. Now you can rewrite this integral. U is 3x minus 4. So instead of 3x minus 4, just write u to the fifth power. And then dx is just du over 3. So u to the fifth du over 3. And then you can put the 3 on the bottom on the outside. So that's a 1/3 integral of u to the fifth du. And now you can just take the integral as normal. So this gives you a 1/3 times u to the sixth, the reverse power rule, over 6, plus c. And 1 over 3 times the 6 on the bottom, that's 1 over 18. Now instead of the u to the 6th, we can put the u back in. U is 3x minus 4 to the 6th power. Now you add c. That's your final answer right here. This one right here, this looks like a mess, right? So remember, when you set u equal to something, here's like a hint. If you notice, inside here is x cubed plus 4. If you take the derivative of x cubed, that's a 3x squared. It's going to cancel out. You're going to see this right here. So let u equal to x cubed plus 4. Du is equal to, let's give us up, 3x squared dx. And then divide both sides by 3x squared. Du over 3x squared is equal to dx. So if we plug this in here now, right? Well, can't do nothing with this is 6x squared. Instead of x cubed plus 4, we have u to the fifth power. But dx is du over 3x squared. If you see here, the x squared on the top and the x squared on the bottom cancel out. That's a cool thing with u sub here. Helps us a lot with solving integrals like this. So if you rewrite it, well, 6 divided by 3, I'm going to put a 2 on the outside. The x squared and the x squared cancel out. And you're left with u to the fifth power du. Isn't that cool? And now you take the antiderivative, so it's 2 times u to the 6 over 6 plus c. And now you can just replace the u with x cubed plus 4. Well, 2 over 6, that's the same as 1/3. U is x cubed plus 4 to the 6th power. Add c. That's your answer right here. This next one here, square root of x minus 1 squared over square root of x. You're going to see if you, this looks really nasty here, but if you use u sub, you'll see things cancel out. So if you let u equal root x minus 1, like the top part here of the exponent, du is equal to 1 over 2 root x dx. And then if you multiply this over, 2 root x du is equal to dx. Now, let's plug this back in, substitute the u's in. So we have a u squared on top over root x, and then dx is 2 root x dx. So if you see here, the root x on the top and bottom cancel out. So, and you just have a 2u squared on the top. So 2 integral of u squared du. Oops, if you didn't, I messed this up. This should be a du, not a dx. My bad there. This is a du, not a dx. Du, not a dx. So now, continuing here, 2 times reverse power rule, 2 to the third power over 3 plus c. Now you just replace the u with what we set equal to here. So it's 2/3 square root of x minus 1 cubed plus c. That is our answer for that one right there. So question 4 right here. So you want to set u equal to cosine x. So du is equal to negative sine x dx, but I'm going to skip a step here. Du over negative sine x equals dx right there. So when you rewrite this now, again, if you set u equal to sine x and you try this, it wouldn't work out. You can see it if you tried it, but then u equals cosine x is the way that would work. So integral of sine x e to the u, and then dx is du over negative sine x. So sine x on the top and bottom cancel out. You're left with a negative e to the u du. Well, and that's just equal to negative e to the u plus c. And then you can put the u back in. So it's negative e to the cosine x plus c. Again, if you tried this with u equals sine x, this would not have worked. You can try it on your own if you want or ask your teacher, but this is the u sub that would work. So this one right here. I'm not going to worry about this one. You can cross it off. This is like a double u sub problem. I'm not going to worry about that one. You can skip question 6 right here, but we're going to do question 7 here. So sometimes inverse trig can be confused with u sub. If you look here, you'll see here. So we're going to set, well, let's rewrite this first. This is 1 over square root of 1 minus 2x squared. And if you look at the arcsine function, the integral or the derivative of the arcsine function, the derivative of arcsine is 1 over square root of 1 minus x squared, but instead of x squared, it's 2x squared. So you have to rewrite this in the form so we can use u sub to help us to match one of the inverse trig identities. So if u equals 2x, and so du equals 2 dx, so du over 2 is equal to dx. You can rewrite this as 1 over square root of 1 minus u squared, and it's du over 2. So now you can bring the 1/2 out front. The integral of 1 over square root of 1 minus u squared, well, that's just arcsine of u plus c, which is just 1/2 arcsine, plug the 2x back into u, plus c. So if you look at some integral problems where it kind of looks like one of the inverse trig identities, like the derivatives or integrals, there's a chance it could be that instead of u sub. Because if you think about it, if we did u sub 1 minus 4x squared, we will get like an x variable, but it would not cancel out with anything. So that's a sign you can see that it is going to be trig substitution. Last two examples right here. Now we're going to do definite integrals in u sub. So the integral from u0 to 2 of this whole thing right here. So what we can do is set u equals t cubed plus 1, du is equal to 3t squared dt, so then divide both sides by 3t squared, dt is du over 3t squared. Very important thing if you have a definite integral and u sub. You see it's from 0 to 2, the bounds are going to change. So the 2 up here, right? You got to plug the 2 into right here. So 2 cubed is 8 plus 1, that's 9. The 0 here, plugged into the t here. 0 cubed is 0 plus 1, that's a 1. Now you can rewrite as you did before. T squared, and then it's the square root of u over du over 3t squared. So the t squareds cancel out, and then you have the 3 in the bottom, so it's 1/3 integral of 1 to the 9 square root of u. That's the same as u to the 1/2 power, and it's du. Now, just use the basic reverse power rule. 1/3 times u to the 3/2 divided by 3/2, and then do the vertical bar from 1 to 9. And then what you can do is just plug this in right here. That's equal to 1/3. Let's do this all on the outside here. So you can plug in the 9 first, 9 to the 3/2, divided by 3/2, minus 1 to the 3/2 over 3/2 on your calculator, and you will end up getting, if you do this correctly, a 52 over 9, or the decimal equivalent. Again, u sub with definite integrals, these bounds have to change. Sometimes there will be AP multiple choice questions that just show the setup, and they want to make sure that you know that these bounds are supposed to change, depending on what you set the u equal to. This one right here, we can set u equal to sine x dx. Oops, u is just equal to sine x, not the dx as well. It's the next line. Du is equal to cosine x dx, and then divide both sides by cosine x. Du over cosine x is equal to dx. Again, so it's the same thing. We have to change the bounds. Plug the power over 2 into sine x. Sine of power over 2, that is just 1. And sine of 0, that's 0. So we have our cosine x square root of u, and then dx is du over cosine of x. The cosine x and cosine x crosses out, so it's the integral of 0 to 1, u to the 1/2, because square root of u is u to the 1/2, du. Now that's just u to the 1/2 plus 1, which is 3/2, over 3/2. Oops, and there's not a plus c because this is a definite integral. You do the vertical bar instead from 1 to 0, 0 to 1. Now on the next line, that's just plug the 1 in first, so that's going to be 1 to the 3/2 over 3/2 minus, plug the 0 and 0 to the 3 halves over 3 halves. If you're doing the calculator, you just end up getting a 2/3. That is your final answer. This is a pretty algebraic intensive lesson. If you need help, please ask your teacher, or there's also resources that you can find online, Khan Academy, other YouTube videos as well. You can go ahead and start the practice otherwise.